Okay, I think we're live. Good morning, good afternoon, or even evening, as it may be for some of you. Welcome to the origin and future of the Grand Canyon, a live conversation brought to you by Annual Reviews and Knowable Magazine. I'm your host today, Emily Underwood, and I am so thrilled to be here with you today to talk about the Grand Canyon and the Colorado River that has carved it over millions of years. I'm delighted to see so many Grand Canyon fans and aficionados in the chat today. Welcome. Welcome to those of you who maybe have never been to the Grand Canyon. Some of you may be wondering what all of the fuss is about. This is not the deepest canyon in the world, or even in North America. The Grand Canyon isn't the oldest canyon or the biggest canyon, but it is one of the best places in the world to learn about geological or deep time, and to think about how our extremely brief human lives fit into Earth's history and its future. So before I introduce our speakers, I'd like to give you guys a few housekeeping items. First of all, because we have 3 speakers and the topic is so grand, we are going to allow it a little bit more time. We're going to wrap the discussion up at 10 and then take 20 minutes or so for questions. We will be recording this and sharing it for free. You can replay it when it's over, and we hope you will share it with others. If you find you can't hear the audio, please refresh your browser. Put your questions in the question box at the bottom of the screen. After an hour of discussion, we're going to go ahead and move to audience questions. And our editors will select from the questions that you post. After the chat, we hope you'll tell us what you learned from the discussion or thought about it. You can do that on Twitter. I'm M_Underwood, and with @KnowableMag and @AnnualReviews. If you want to help us keep making these events and high quality science coverage freely accessible to all, please consider donating at knowablemagazine.org/donate. Finally, the best way to find out about our future events and everything else that Knowable publishes is by signing up for our newsletter. And I'm hoping that Katie and our other staff will put the link to the newsletter in the chat. Please sign up. All right, let's meet our speakers. First, I'd like to introduce Dr. Crystal Tolle Cordova, a principal hydrologist for the Navajo Nation Department of Water Resources. Crystal works to protect and manage water resources in the Navajo Nation, which is located alongside the Grand Canyon and almost entirely within the Colorado River watershed. And she will talk to us more about that in just a second. So welcome, Crystal. Next, I would like to introduce Dr. Laura Crossie of the University of New Mexico. Laura studies how rocks interact with water in the Grand Canyon and many other places all around the world. Her work takes us to hidden springs and dripping caves and these gorgeous mineral deposits called travertines. Last, but certainly not least, please welcome Dr. Carl Karlstrom, a geologist at the University of New Mexico and an authority on the geologic history of the Grand Canyon. Along with Laura, Carl has been a decisive contributor to long-standing and very spicy debates over the Grand Canyon's age. I am glad you are all here. Okay, to begin, I would like to start with each of your personal connections to this area. How did you come to study this region? What does a typical day in the field look like? And I would love it if, Crystal, you could start us off.
Hi, and I am Crystal Tolle Cordova, and Twitch 18 Nishla Tatnes Ahni Bashichin, Hashkan Henzoha Edashiche, Tuo Heglini Edashanele. I'm of the Bitterwater clan, born for the Tangle People clan. My maternal grandfather's clan is the Yucca Fruit Strung on a Line, and my paternal grandfather's clan is the water that flows together. I grew up in the Navajo Nation, and as an early explorer, had the opportunity to be able to benefit from the water that comes from geologic formations that are exposed in the Grand Canyon. And within this area, also had the opportunity to be able to have interaction across the landscape, being able to experience the different water that flows through the Canyon and helps carve out that system. And with that being said, the stratigraphy is really interesting, but also very interesting to me as a hydrologist is the water. And so a day in the field as a hydrologist really looks like observation, being able to think of the system holistically, everything from the precipitation that falls and the bimodal precipitation regime that we have in this region, receiving water from the precip in the summer from the North American monsoon and then experiencing winter precip. But as that flows downstream, being able to flow through perennial and ephemeral systems, but also recharging that groundwater. And it's important for me to be able to share some of those perspectives today and how the Navajo people in this region rely upon the water, but then also have familiarity with the geologic formation. And a part of this is the philosophy that we have. The English words are three words that make a sentence: water is life. But when we really think about it, it's all encompassing about our livelihood, our vitality, and our identity as Indigenous people in this region. And we rely upon, although we're talking about the Grand Canyon today, it's important for us as Indigenous people to think about it more holistically and not just thinking about the geology that's within the system, but really thinking about the overall system, the water that is there, the geologic formations that's there, but then also to think about the plants and the animals for which we have sustained our livelihood in this region for millennia. Thank you.
Thank you so much, Crystal. Just for setting such a beautiful tone for the rest of our conversation. I'd like, Carl, would you like to go next, talking about sort of what a typical day in the field is like for you and where you ramble? If you would like me to bring up one of the slides, just let me know which one and when.
Okay, great. Well, it's a pleasure to be here. For full disclosure, I think we have to say Lori and I are married, and so we do a lot of work together, and a typical day in the field is hiking together and sampling rocks together and sampling water together, mapping together. She's a photographer. I do a lot of the other aspects of geology, but we spend a lot of time in the Grand Canyon. It's not our only field laboratory, but it is a special one and very deep connections to it. I grew up in Flagstaff, Arizona, and started hiking in the Grand Canyon when I was about 16, and became a boatman and a rock climber and a hiker before I became a geologist. And now I've managed to carry on with those great activities while also studying the history of the Earth through the rocks and the landscapes at Grand Canyon. It's an exciting place to work, and we got decades yet to go to understand more about every aspect of the rocks and the landscapes.
Great. Lori, do you want to take the stage and just let me know if you want me to bring up the Colorado Plateau picture at any point.
Sure. Thank you. Thanks, Noble and Annual Reviews, for bringing us all together this morning. It's just going to be a really fun team. Why don't you put up the Colorado Plateau? We can see we have visitors literally from all over the world. Some of them, it's probably the middle of the night, but that would remind them on slide number 1 kind of where Grand Canyon is. I myself didn't grow up in the Western United States. I come from the area of Chicago, and my home is a few miles from the shores of Lake Michigan. I found my way to the West going to school in Colorado, and that was my introduction to places like the many beautiful Western landscapes we see on the Colorado Plateau and in the Rocky Mountains. I came to New Mexico as a professor after finishing my graduate degrees, and it was probably when I was an undergrad that I first went to Grand Canyon. I was already a geologist when I first saw the canyon, so that's a pretty different experience than both Crystal and Carl, who saw it, under a different framework. I'm not exactly a hydrologist. I'm a geologist, but I'm trained in geochemistry. So that sort of colors my sort of personal interest, my research interests in the Grand Canyon region. And so I study both the water, the rock, and the deposits that form from the water, that is the travertine. So a day in the field for me is often either hiking or rafting. We're very lucky to have the support of the National Science Foundation, which enables us to have a floating research facility, which is a couple of rafts. And we are able to go down the river with teams of scientists and students and work on different aspects of the geology. So it's really interesting. If you look at the map of the Colorado Plateau, the black box is kind of circling the Grand Canyon region itself, not the entire watershed of the Colorado River, but the Grand Canyon, a very large feature. And if you're accessing it from the river, you go from one end to the other, you're floating through an amazing array of geologic problems. And so a river trip becomes a practice and a set of logistics of working on the problems as you're in the proper location. So it's a very place-based kind of driver for research. And so we can go from one day working on the oldest rocks in the canyon, the next day sampling active waters and some of the youngest rocks in the canyon. So a day in the field is in the Colorado River is always a challenge to get yourself in the proper framework of geologic time.
I love hearing about science on the river. It sounds amazing. So just that big picture gave us a sense of some of the geography, but I want to just talk a little bit more about, what is the Grand Canyon? Where is it? Where does it start? Where does it end? What are we talking about? So Carl, can you kick us off for that? And I'm going to go ahead and bring up the beautiful slide.
Yeah, we need to be looking at it for
visual.
sure. Let's look up at a picture of it. The Grand Canyon is so many things to so many people. Where to start? It's you have to see it from all perspectives. You can see it from space, of course. You can see it in an airplane. You can see it on the rim looking down. It's a thing when people walk to the rim, they just take a gasp of even you've seen a million pictures. Going to the rim it's way better than seeing this picture, believe me. And then you got to hike down to get a sense of how deep it is. And if you get a chance to float the river, you get a sense of how long and how varied it is and how many rocks of different types there are. But this particular view is what you see from the south rim of the Grand Canyon. And at this point, it varies in width, of course, but I like to say it's a mile deep and 10 miles wide. And that sort of gives you an impression. It also gives you a concept, which is, although the canyon is remarkably deep, it's also remarkably complicated. And it's the tributaries as they've eroded the walls of the canyon that make it so wide and so varied. But, you look at this picture, and I don't know how many geologists there are out there, but to a geologist, I immediately see those basement rocks down in the bottom, the oldest ones. And then I see a bunch of layered rocks, and I even see some tilted layers in there because I know what to look for. And then I see a bunch of horizontal strata with marvelous colors, including the Coconino sandstone, that bathtub ring toward the top before you get to the Kaibab surface. So the thing about learning a little bit of geology is it really enhances your understanding of the earth and your experience as you go to all these marvelous places. A geologic perspective, I feel so lucky to have to be able to look into these rocks, understand a little bit about the stories of each of the rocks themselves, and also the story of how this river carved down through the rocks. You can't even see the river in that view, but believe me, it's a powerful river at the bottom that's carved through solid rock to make this canyon. I can go on forever, but I think we should. Oh yeah, okay. That's so. When we get to the question about the age of the canyon, it's nice to know the geography a little bit better. So the picture we just looked at, it was looking from the place that's the south rim there, little dot looking north. But when we run the river, we launch our boats at Lee's Ferry, river mile 0. We float south. The river goes south till it hits a little past the Little Colorado River, and then it takes a wonky right-hand turn and goes across a thing called the Kaibab Uplift. This has been a puzzle or a research topic for a long time. John Wesley Powell said, why do these rivers cut across the uplifts? Wouldn't you think they'd go around? But it doesn't. It cuts right across the Kaibab Uplift. And then it hangs a little bit of a left through the Muav Gorge, and there it's just super steep and super narrow. Hangs a left and goes down straight south along the Hurricane Fault, and then turns right and heads out to the Basin Range. So if you just know that the canyons in segments and the names of them, Marble Canyon, Eastern Grand Canyon, Muav Gorge, Hurricane Segment, and Western Grand Canyon, we get to have a little better way to talk about the history of this development of the canyon.
Awesome. Thanks, Carl. Just for one last bit of orientation, I would like Crystal to talk about where the Navajo Nation is in relative to the Grand Canyon. So I'm going to go ahead and turn it over to her.
Thank you, Emily. The Navajo Nation is adjacent to the Colorado River, as well as to the Grand Canyon, present day Grand Canyon. But I think, based on the image that we saw earlier about the Colorado River Plateau, it's in the central part of the Colorado River Plateau. But when you think about the present day area of the Navajo Nation, it straddles both the upper and the lower Colorado River Basin. And in this map here, what you can see to the left of the Navajo Nation and basically to the west, you can see where the Grand Canyon is. And you may be wondering what the colors are representing. We have 110 Navajo communities that are located a part of this major area, but then we also have 3 satellite communities. One that is the Tuahajile area, that is west of Albuquerque, and then also west of Socorro is the Alamo area, and then south of Gallup, New Mexico is the Alamo area. And it's important to consider, as we begin to talk about the geology of the Grand Canyon, but also is the hydrology and being able to talk about the future of this region and being able to have knowledge about things that we'll all go deeper into later about the Navajo Nation and the homes without pipe water access. So thank you for sharing that.
And so rocks, water, we're going to get to it all. We're going to talk a little bit more about rocks now before we move back to the water that flows through them. So people, naturally focus on how majestic and grand the canyon is. But the main reason geologists get excited about it is that it is such a remarkable window into Earth's history. So Laura, you have described a million years as just a heartbeat for the Earth. And I'd like you to talk a little bit about how old the oldest rocks to be found in the canyon are, how much of Earth's history they represent. And, this is a question that you're all welcome to chime in on, but I just wanted to start with Laura.
Great, thank you, Emily. If we go to the view from the South Rim again, that will just kind of remind us of what a person sees from the rim looking deep into the canyon. Because of superposition and the idea that the younger rocks are on top, we sort of, especially those of you that are already geoscientists, we know that the youngest rocks are up at the rim, and as we go deeper into the canyon, we're going back in time. But it's not an even exposure of geologic time. Rocks represent time, but there's often missing time. So there's been a common analogy of thinking of rock layers as maybe books or an encyclopedic set of books where each book is a formation which tells its own story. And when we look at this view from the rim, down deep into the canyon, we're looking down into the oldest rocks of the canyon. Sometimes they're just euphemized as the Vishnu basement rocks. The Vishnu rock layer is actually the Vishnu schist, and it's just one of many, many types of basement rocks that we find, not just here in Grand Canyon, but of course, the basement of all our continental land masses have rocks that are stretching way back into the mists of the early Earth. Here in Grand Canyon, the oldest rock that we know of is 1.84 billion compared to 4.56 billion years for our planet. That means that here at Grand Canyon, you're really looking at about half of Earth's history with many gaps in between. So we have the basement rocks, which we're just getting a glimpse of here in this view. And then, as Carl mentioned, there's a set of tilted sedimentary rocks. That's the sort of in-between time that's recorded here in Grand Canyon. And then as we come up to the flat-lying rocks, we come to the younger set of rocks. And then decorating this beautiful layer cake, in a way, the icing, if you could go to the next slide, Emily, we would get a little glimpse of some of my favorite rock, which are the youngest rocks forming at Grand Canyon.
Actually, that's number 5 there.
Yeah, thank you. Thanks, Carl. Yeah, so if we go to slide number 5, there you go. We're looking at some of the beautiful travertines. Crystal has spoken about the Navajo Nation and shown us an example. There are 11 associated tribes with Grand Canyon National Park. And on some of these tribal lands, we see things like Havasu, along the Havasu drainage, that's the picture on the left, beautiful Mooney Falls. And in the foreground is this gorgeous draping travertine mineral deposit. Think of it as the deposits from hard water. And in the center panels, we're looking at beautiful rimstone dams and terraces. They're cementing up sticks, twigs, even things like picnic tables, because this rock can accumulate very, very rapidly. In a way, it's water turned to stone. And like using a speleothem in a cave, we can use the rock to go back through time and tell us about past hydrologic conditions. So the travertine record at Grand Canyon is spectacular. If the canyon wasn't there, the travertines alone would be worthy of having a national park. So these are all really fabulous. And if you go to the slide of the cartoon drawing of the rock layers, that's slide number 6, I think.
The one just before this,
Next,
I think. No, you're right. One just next, yeah.
The next one after.
There you go.
Yeah, there we go. This is a cartoon version that is sort of puts together the concepts that we wouldn't see in any one view necessarily, where we see the Colorado River on the left-hand side. It's a cross section as if we have had a huge road cut through the geology, which the Colorado River has given us by carving this magnificent canyon. We see the oldest rocks kind of in gray tones at the bottom. Inset into there, we have faulted and tilted layers of the Grand Canyon supergroup. Then we have another unconformity, which we'll talk about, maybe later on. And on top of that are the beautiful layer cake stratigraphy of Paleozoic rocks all the way up to the Kaibab Formation. And then, as I said, decorating this stratigraphy like icing, we have beautiful quaternary volcanics, many, many basalts that are flowing down over the rock layers, and also the travertines, which are sourced from groundwaters, the kind of groundwaters that Crystal talked about, coming out and then precipitating on the Earth's surface. So this is sort of a snapshot of all the 3 sets of rocks that we think about, plus the modern landscape and some deposits associated with that. And I should mention, of course, the stream terraces that flank the river along its length, big, beautiful gravel bars and young terraces.
Sorry, I couldn't help myself just dancing along the beautiful basalt. So I would love, thank you. And so these travertine deposits, there are many types of evidence that you use to reconstruct the history of the canyon. And it has been a long and sort of controversial debate around the age of the canyon. So Carl, you recently wrote an annual review summary. I'm sorry, I have skipped ahead. So some of these rocks date, nearly 2,000 million years, long before animals showed up. This is when slimy algae ruled the earth, if I have that right. But the canyon itself is not that old, right? So Carl, you've been a big player in debates over the Grand Canyon's age, and these have gone on for more than a century, right? So how has that conversation evolved, and what do the most recent data suggest?
Yeah, thanks for that statement you made earlier that the the canyon is young and it's carved through very old rocks. And for visitors to the Grand Canyon, that might be kind of the most fundamental starting place, an old rocks in a young canyon. But the age of the canyon, if it's hard, isn't it? You have to figure out the age of something that's been eroded, something that's gone. So how do you do that? The techniques we have gotten better and better over the 150 years of discussion, about more than 150, about discussion of how the canyon was carved and when. And it has been a big debate. But I think we're at a point now where we have reconciled ideas that have come along through different generations of geologists and new techniques, including better dating and better thermochronology, which is how rocks cool as they come to the surface by erosion. And so the reconciliation, I'll just give the answer and then we can show more details. But basically the canyon's less than 6 million years old. That is, the Colorado River came through and reached the Gulf of California at 5 million. So it was coming through the Grand Canyon region between 6 and 5. That's young for a geologist, only 6 million years ago. What a time perspective. But when the water came from the Rockies through all the way to the sea, it was because of very interesting things like climate changes and geomorphic changes that are still being debated. So the details of how the river got integrated from the Rockies to the Gulf are still very much active research topics, but they involved, in this Paleo Canyon solution, we call it, it involved the water finding low places. There were landscapes around, and so it found a low place, a partial canyon that had been cut in the light blue there by a Paleo Little Colorado River. So the Colorado came down and took a hard right across the uplift because the uplift had already been cut through, in part, about half the depth of Grand Canyon today. So when I stand on the rim and I look out into the open space, I imagine an old Paleo Canyon up there in the air because we've identified that based on thermochronology. And then another old Paleo Canyon is that dark blue line where the rivers were actually flowing north. And they went through that one segment, carving it partially, maybe again about halfway, and heading off towards Utah. So this idea that the Grand Canyon has these different segments, each with slightly different histories that were linked together by the Colorado River when it came through about 6 million years ago. I believe that's now a reasonable consensus amongst the community. Consensus doesn't mean unanimity, but there's just lots of evidence now, and this idea reconciles, I think, many of the problems that we've been debating about for years. So 6 million year old Grand Canyon, but there were older segments that got linked up.
Great. And can you talk a little bit about the bigger context of, what the Grand Canyon is carving through? So you recently, you published, were co-author on a paper about the history of the Colorado Plateau. So this bigger grand story, which is full of these amazing phrases like intraplate thick-skinned origin and collapsed back arc hinterland. And it sounds very exciting. It sounds like a battle between trolls or something, which shows how much I understand it. Can you please share a few highlights of what that story of the Colorado Plateau says? I'll bring up the slide for you.
Yeah, I love misconceptions. I'd like to write a book someday on misconceptions. And one misconception is that the Colorado River just carved straight down from the Kaibab layer and created the Grand Canyon. But I've already tried to debunk that one by saying that there was obviously older landscapes that got hooked together. Another concept is that the river, the power of the river, using rocks as grinding stones and tools that carved the river, that the river itself carved this canyon all on its own. And this Colorado Plateau paper that you mentioned, we make the case that actually the Colorado Plateau has been uplifting to create the marvelous landscapes of the Western U.S., the Rockies, the Grand Canyon. Why are these landscapes so spectacular? In this model, it's because the land is uplifting through the buzzsaw, through the river, to create these canyons. Hey, Lori, do you want to tell them how we cut cakes at home?
Sure, happy to. If you can imagine the last birthday that was perhaps in your family group, somebody will bring to the table a beautiful cake, and then someone will pick up a knife and cut the cake. Well, at our house, when it's Carl's birthday, it takes about 5 people. You set the cake on the table, and Carl holds the knife over the cake, and then the other 4 people lift the table up through the knife to cut the cake. So that's this idea that Carl's talking about, the dynamics between a landscape, and changes that are happening, tectonically driven within the earth, versus the superficial forces of the water cycle that Crystal will take us through, working away to erode that landscape, not just the buzzsaw that is the river itself and its incredible tools, but also the landslides, the sheet flows, everything else that is happening to widen the canyon.
Thank you so much. That is such an excellent introduction to water. And again, this is such a huge topic. We could talk for hours and hours about rocks alone. We could talk for hours and hours about water alone, but I'd like to go ahead and start talking about water. So let's see. Crystal, I'm curious about how you think about water in the Colorado River watershed as a principal hydrologist for the Navajo Nation, and also as someone whose ancestors have lived in the region for millennia. So can you go ahead and get us started on some of the hydrological perspective?
Sure. I don't know how many of you learned about the water cycle, but here I learned about it in about 4th grade. And with that being said, I couldn't really connect to the water cycle image that was shared in 4th grade, but the image that I had was really related to the place that I come from, and being able to experience living on the land and being able to be familiar with the different components of the water cycle, including, and Emily, can you bring up the image of the water cycle that I've shared? And through this, you can see all of these are taken on the Navajo Nation and be able to see the water cycle that we experience. And so it's really more of an intimate connection with water. As I mentioned previously, the Navajo people really have this deep connection to water that extends, we're appreciative for it for a varietality. And as a hydrologist, having the formal training, being able to learn about geology, being able to learn about water-bearing units and confining layers, it really broadened my understanding, being able to interconnect the traditional ecological knowledge that I grew up with, basically using that place-based knowledge from the area that I grew up in, growing up with my grandparents and Indigenous people. Often, we don't pass textbooks down through our generation or written journals. More, it's an oral history of being able to describe things, how they've changed over time, and being able to share as well the importance of different sacred areas as it's connected to near the Grand Canyon. We've seen pictures of where the Little Colorado River and the Colorado River meet, which is the confluence area and is an area very special to many tribes, not only the Navajo Nation, throughout this region. And then also in the San Juan River, there are many areas. So the Navajo Nation is also adjacent to the San Juan River. The northern part of our Navajo Nation runs along the San Juan River. And just having that understanding of being able to, use the knowledge that I gained ever since growing up with my family. We live in multi-generational households, and that knowledge is knowledge that I couldn't gain from a textbook, but I'm really appreciative of it because it provided a greater love for the sciences and being able to learn the things that Dr. Karlstrom and Dr. Crossie have talked about, and being able to show, explanations of how old rocks are, and being able to have the understanding of how things have changed over time. And one of the things that's most fascinating to me, especially when you look at water, right? You think about a glass of water perhaps on a table, and what you don't maybe really fully understand until you've seen these things and experienced them is how strong water is and how water can be able to form these magnificent features throughout the Southwest and be able to expose rocks that weren't exposed prior. And I just find it very fascinating in the work that I do, and also really appreciative of being able to expand my knowledge using both the traditional ecological knowledge that I grew up with, but then also the knowledge that I gained through, undergrad and graduate school to be able to deepen my understanding of the Grand Canyon region.
Thank you so much. So you mentioned the Little Colorado, and something that we're looking at right now, this confluence, and something that occurred to me as I was researching this conversation was that, you and Lori as hydrologists, when you look at the Grand Canyon, you look at this broader area, you are seeing so much that's hidden to the eye for most people. So I would love it if you and Lori could talk a little bit about what you see when you're looking at a confluence like this. And maybe, do you want to speak about that a little bit? And then we'll turn it over to Lori to talk about sort of springs and travertines as well.
Yeah, sure. I'll go ahead and get started on that. So what I see when I look at the confluence, and I've had the great opportunity to be able to drive over rocky roads to gain access to the confluence and overlook this area with my sister and my son. And you can also see it, there's a tribal park that's near the area as well. But what I really wanted to be able to see were the geologic layers from above and be able to see where the waters meet. And, what I see as an Indigenous person when seeing this area is also thinking about, where the water is coming from that is flowing both within the Colorado River and then also the Little Colorado River. And being familiar, upstream of the confluence is Grand Falls. And so my maternal grandfather came from that region. And so being able to know that the water, even above Grand Falls, starts in the headwaters of sub-watersheds that go across the Navajo Nation. And being able to see, that precipitation changing into be able to add to the ephemeral streams, the perennial streams, the groundwater, and being able to see it flow. I've also had the opportunity to go from the headwaters down to the confluence area and just being able to see, thinking holistically about the water through the system, because I think sometimes we compartmentalize different components of the water cycle, but in thinking about the water in this region, it's very important to think about it holistically, really having that understanding of how precipitation contributes to this region. And then just thinking about the flow paths, groundwater flow paths, surface water flow paths, and being able to see, in areas like this. And the importance of the confluence is a very sacred place where Indigenous people for millennia have made offerings for continued vitality throughout the next generations, and being able to, have the spiritual connection with the land and with the water in a way that's very unique for this region.
Taking me a second to unmute myself, sorry. So Lori, can you tell us what you see when you look at this confluence and sort of the hydrologist, your perspective on the hydrologic systems underneath all of these rocks?
Sure. There's kind of three big points that I'd like to make. Number one, we're looking at the beautiful layered rocks, and just as it's telling us about Earth history, it's also telling us about a hydrostratigraphic framework for groundwater. So as a practicing hydrologist, especially one who focuses on groundwater, I'm sure Crystal many times has looked at what they think is the hydrologic framework for different parts of the Navajo Nation, the Colorado Plateau, and the Grand Canyon region. And so here we're visually seeing this series of aquifer units, which there are multiple aquifer units. The Upper Kaibab, if we were in Kentucky, that would be a fantastic an aquifer unit, but unfortunately doesn't have any water in it. So that's a big problem. But as you come further down, the Coconino serves as a very important aquifer in some of the distal areas of the plateau adjacent to highlands where it can get runoff and snowmelt. But then as you come below the Coconino, you come to the major regional aquifer, which is the Redwall Muav. That's a combination of these flat-lying Paleozoic units. If we look at this picture, our eyes can, by color, we can see the difference, the fundamental difference of two very different pathways. And Crystal has outlined the journey that she would take going from the headwaters of the Little Colorado, coming all the way down to this important confluence. And we see that water is sort of a turquoise blue color, whereas the Colorado River, which it's joining, flowing from left to right in this picture, is in a way it's an interloper. It's coming from the high mountains of Colorado. It sits in a reservoir. The reason it's green at this moment in time in this photograph is because it's being released from the dam. In times immemorial, the Colorado River itself would go down to quite a low flow condition, but we maintain it at a fairly high discharge rate artificially through the Bureau of Reclamation and the operations of the dams that's at the head of this segment of Grand Canyon. And so the water on the right, the turquoise water, is fed by groundwater springs. So unless there's water, muddy red water pouring over Grand Falls and a big runoff event, in which case both of these rivers will look very red, hence the name Colorado. But in the case of the groundwater flow, we're looking entirely at groundwater in that turquoise water. And it has the chemical characteristics of precipitating this beautiful travertine. It lines the bed with this white material, and it helps give us this Caribbean kind of blue aspect to this water that is just so amazing. So that also reminds us, if we're an ecosystem, kind of tying in with the traditional ecological knowledge, if you're an organism living in a little cluster of vegetation, it's the groundwater fed springs and the streams that they feed that are the only perennial water sources in this arid region. And a big flood can come by and provide a lot of water and help fill a reservoir like Lake Mead. Most of that is coming from these huge high discharge monsoonal events and maybe the pulse of the snowmelt. But aside from that, if you're living 24/7 by the side of one of these drainages, it is that groundwater that you see day after day, millennia after millennia. So we have endemic species, we have incredible ecosystems, and people that have learned to live and sustain themselves with that groundwater flow. There's not one river in Arizona that's perennial that does not have springs and groundwater as its sustaining feed for most of the year. So groundwater is extremely important.
So we're talking about this water as though it's there all the time or going to be there in the future. Let's back up a little bit and talk about kind of the bigger picture of this historic drought that is affecting the West. Driest 22-year period since 800 AD, according to John Oliver on Saturday. Anyway, it's a huge drought, and water supply is a huge concern throughout the Colorado River watershed, supply for 40 million people. I'd like to talk about sort of what that big picture looks like and how how the more local groundwater studies that you do connect to that bigger picture of water supply. And Crystal, do you want to go first?
Yes, definitely thinking about drought, climate change impacts, and climate change impacts on Indigenous communities may look a little different. For Navajo Nation, the populations that may be vulnerable to public water systems, ranchers, and agriculture, and then there's also increased occurrences of wildfires in this region. And as we begin to continue about drought, it's important to also consider what the water portfolio may look like. And for different, you mentioned the number of people that rely upon Colorado River water. And it's important to also understand what are mitigation efforts that are being done to be able to help with levels at PAL and be able to have that knowledge about the intersection of water, of energy with food in this region, and how all of those come to play. There was a Federal Register notice on Friday about, just talking about the mitigation efforts from the Bureau of Reclamation. The Bureau of Reclamation operates the Colorado River Basin reservoirs. But as we begin to think about that, it's also important to consider the groundwater supply. We've heard from Dr. Crossie about the groundwater and the interconnections with surface water as well. And for the Navajo people, it's important. I don't know how many people, have an understanding, but up to 40% of Navajo residents don't have pipe water. And when you consider that, and you consider the climate change impacts of drought in the region, through water rights, secured water rights, we are diversifying our water portfolio by being able to create a hybrid system of surface water and groundwater. This map shows the number of homes that don't have pipe water. The red indicates more than 200 homes that don't have pipe water. And what you can see for the northern area, that's the communities of Navajo Mountain, Oljeto, and that's along the San Juan River Basin. And as we begin to consider this effort, it's also important to consider, like, what are the challenges and what are the opportunities there? And why is there such a large population of people that within the US that don't have pipe water? And those challenges stem from a variety of issues, either the need for capital development for water infrastructure, aging infrastructure, but then also in this region, there are legacy issues associated with water quality impacts on water sources that people would use. There's a lot of papers, videos out there that you can be able to have that understanding, but there are over 521 abandoned uranium mines within the boundaries of the Navajo Nation. But also in this region, on the southwestern region of the Navajo Nation, we have brackish water challenges as well. And so really salty water that we need to be able to create technology to help improve the water availability in the system. But through different opportunities, this unprecedented time does provide some funding under the American Rescue Plan Act and the Bipartisan Infrastructure Law funding to be able to help infrastructure within this country, and particularly for this region, to be able to provide opportunities to address those water challenges that I've explained, and be able to, talk about ways of how that can improve the continued vitality of Navajo people within this region for continued generations into the future.
Great, thank you. I have a few more questions I would love to ask you, but Carl, is there something you want to add to that?
If you put the picture up just to give people a visual on that that confluence picture. The Navajo Reservation borders all the flat layers we're looking at there. Are the plateau above the canyon is Navajo land. And they've been here a long time. And yet the water in the river was allocated without their voice. And it was over allocated. So this drought is bringing out not only problems with how the river water is over allocated today, but it's bringing out these problems of, so all the rim areas beyond the river there are Navajo land, and that water, that's the green water that's going by, is way over allocated to Las Vegas and Southern California and Phoenix, and even in the upper basin it's over allocated. So this is a problem for the generations. It's linked to so many important issues of infrastructure, of indigenous rights, of simply how you think about water allocation. And Powell said 150 years ago, we couldn't draw boundaries along states and we had to think about the water. And the groundwater, the blue water there, the turquoise blue water, doesn't know about boundaries. It doesn't know about the tribal lands. It doesn't know about the park lands. It's a water resource underground that we have to figure out how to cherish. It's a scarce resource for the future. So I think that confluence picture brings a lot of those thoughts to my mind.
Emily, I have a request. If you could show the threats slide, which might be 11 in your deck. Just
Yeah, I'd
because
be happy to.
we have such a wonderful viewership here, and sometimes people they're hearing about these issues, probably not for the first time, but maybe so. And I just wanted to point out to amplify what Crystal brought up about the legacy from uranium mining. It's not only a legacy; it's an active battle right now in the Grand Canyon region about permitting old approved mines to operate. And so this map put together by the Grand Canyon Trust, and I think you could maybe put the link in the chat. The trust works with tribal representatives and has focused on a lot of issues across the Colorado Plateau. But in particular, right now, the things I want to highlight are the uranium mines. These are not just the tailings, which are distributed around as a legacy all the way, much further than just the Grand Canyon area. But these are deep mines in breccia pipes that have huge water issues because they have to mine down at depth. They have to dewater the mine. They have to dispose of the water that is produced as they're doing the mining activities. So if you look to the south, you can see the Pinyon Plain mine, which was called the Canyon Mine. And then to the north of the canyon, there's the Pine Nut and other mines. Then there's the trucking of the material across the Navajo Nation and through urbanized areas. So there's a whole host of problems, but just from the threat to water, these are legislative issues that are underway right at this moment. So, go check out what's happening there. Anyone who understands the complexity of the groundwater in this region would say that it is, even though the groundwater is old, it is still impacted by small amounts of recharge that do make it to those old groundwaters. Confined aquifers are not perfectly confined. They've done tracer studies where they've dumped water on the North Rim. It went 90 degrees to their groundwater flow models and showed up 50 kilometers away from the injection point in less than 2 years. Not all of the water. But it was mixing in. And if you have things like uranium, it only takes a little bit to essentially foul all these precious springs and waters like those source waters of the Little Colorado River. So this is something that needs action. And I just wanted to emphasize that. Groundwater development, communities like Williams, Tucson Valley, that are developing deep groundwater wells, those have the potential to change potentiometric surfaces and shift the groundwater flows. In most cases on the South Rim, that would draw water away from the South Rim, and it could potentially be like turning off a faucet to those precious springs and dripping hanging gardens that those of you that have rafted down the Colorado find a very delightful place.
So I'm looking at the time and I want to make sure we leave plenty of time for questions. Is there any sort of last thoughts before we move to questions that Crystal you'd like to share, or maybe we'll start with Crystal, and then if Carl or Laura, you want to add anything, we'll wrap up.
Yeah, I just want to highlight and raise up what Carl had brought about, Indigenous people being in this region for a long time, but at the same time, the policy of the Colorado River being able to not be a part of that. This year is the 100-year celebration of the initial foundational document for the law of the Colorado River. But what, is not including in that, and it's because Indigenous people were not thought of to be included in that effort with the 7 basin states, is being able to have them signatory to that foundational document. And fast forward to the 100 years later, there's still the need for inclusion of Indigenous communities in the processes, especially as we begin to think about the post 26 guidelines, essentially what will be replacing the 2007 interim guidelines, which operate the reservoirs within the Colorado River Basin. And so there's still a need to be able to include Indigenous nations, and they have a significant water rights holding that are secured. And we also have a large unresolved water rights for the 30 tribes in the Colorado River Basin. But those are just important things to consider as we begin to think about not only the geology and the water, but then also thinking beyond that and thinking about not just the science, but also the policy associated with that.
Great. Are you guys ready for questions? I'm just seeing such an amazing list of questions. Before we turn to questions, just a reminder, sign up for our newsletter. Link is in the chat. Follow us on Facebook and Twitter. And our next event is going to be in September. So please sign up for the newsletter to stay in the loop about that. Okay, turning to audience questions. So I want to start with a question about what else is in the canyon aside from rocks and water. We could have spent yet another, hour talking about the ecology of the Grand Canyon. I think this is a really important point because if you look at it and you don't know much about it or you haven't been down there, it looks kind of barren. So Peter Weiss, actually from Knowable, asked, do any parts of the canyon region have trees or other greenery? Why does it look so barren? Let's talk about what grows. What grows in the canyon and the beautiful ecosystems it supports. I'm going to go ahead and Carl, why don't you start, and then Crystal.
A scientist, I think his first name was Francis, but Miriam was his last name, defined in Grand Canyon and around Flagstaff this concept of vegetation zones. And as you go from the bottom of the Grand Canyon to the top of the San Francisco peaks, you go through 8 vegetation zones, the highest of which is like driving north to Canada, and the lowest of which is like driving south into the Mojave and the Sonoran deserts. So there's all these ecosystems that coexist in one place, which makes Grand Canyon an ecological laboratory as it is a geological laboratory. And I'm not an expert on that, but it's fascinating. And the microclimates that you can go through. So you can find fir and spruce trees below the rim in Grand Canyon that are relics of an older time with colder climates. And now they only exist at the top of the mountains nearby. And so the idea that climate change is shifting these vegetation zones, and that these ecosystems are dynamic, they're changing to respond to the conditions around them. That's a marvelous, marvelous area that Grand Canyon ecology can contribute to.
When I go to the Grand Canyon and the species of plants that I see there, I see the species of plants that you use the bark that was used for, like, my dad and his time period of creating the cushion for his cradle board. And then I see the species of plants that are created to make a cradle board. We didn't have cribs and those type of things, but a cradle board is what he had and what my grandmother provided for him. I also see, along some of the riparian area are also plants that we've relied upon in our diet, either for tea or medicinal plants. Long before we had pharmacy companies, we relied upon plants in this region to be able to use some of that. Those resources to be able to, for different health ailments that might be there. As an example, the juniper ash was included in our diet, and that within the blue corn mush provided what we needed. We didn't have milk, but it provided the essential nutrients that you would get equivalent from the diets that we've had. And so, also seeing the different animals that we've relied upon for subsistence in that area. And, our family today still relies on some of those communities. I think sometimes, when we think about boundary areas like what the Grand Canyon National Park is, we fail to mention like how the different species, either the plants and the seeds that are carried by birds, or either how the animals migrate, and even the insects. And so just thinking about things holistically, although the boundary of Grand Canyon National Park is there, but that within this region, it supports an overall ecological system that is there and present because of the water that is available within that system.
Lori, you want to add anything to the vegetation question?
Sure. I get we could bring in some of the other tribal people, the indigenous cultural landowners here in the Southwest. For example, the Wallapai, the people of the Tall Pines, and so their lifeway, and I think for many Navajo as well, who did a lot of sheep herding and pastoral activities in addition to farming. Right, the beautiful agricultural infrastructure that has been used historically to move water around in such an arid land. But other tribal folks as well took advantage of the pine cover on the North Rim, for example, which is much more heavily forested at a higher elevation. And then they would migrate down sort of seasonally. People would use these different zones. They would farm near the river, had agricultural lands, had storage, had the capacity for storage. And then that kind of brings today, many people of the many people viewing this, sometimes they think about, Crystal, you can kind of attest to this idea as a tourist comes into Tuba City or so forth, and they're sort of expecting, they're surprised that there's actually Indians who are alive. They think of it as some historic thing and not the vibrant communities that we have in the indigenous peoples that are surrounding the Grand Canyon region, just as one example, but of course all across the globe. And so seeing that and the traditional ecological knowledge is one of the things that will help us through these dry times as we incorporate that into our thinking, into our management, whether it's for forest fire or for agriculture or for the kind of food stocks that can thrive through a climate change time, which we are definitely looking at.
Crystal, do you want to respond to that, Nineveh, or should I move on to our next question?
Yeah, I think, just thinking about the area that we're in and the system that is there, it's really just important, to note that there are over 574 tribes federally recognized. That doesn't include state recognized or unrecognized indigenous people. So that means, we don't all speak the same language. We don't all have the same culture. We're in different regions throughout the United States and different U.S. territories. And so just having that understanding is important to think about, in management practices, what might have existed prior to the current management framework that may exist now.
One facet of that is the renaming that we're sort of heading into in this area and has happened, worldwide in many different places. And for those of us that are involved in actually making maps, and so forth, we're going to have some exciting changes to come. And one that's happened right in Grand Canyon is a place that's very heavily traveled on the corridor trails, is what was called and mapped on our USGS topo maps as Indian Garden, so named for an actual family and group that was evicted early on by the national park. Now that is being renamed, has been renamed to Havasupai Garden, and I think we'll find many new names that I'm looking forward to getting used to and to utilizing in the future to just remind us all of that heritage and that component of our living landscape today.
Okay, thank you. So our next question is about the lava flows that have changed the course of the Grand Canyon over time. Let's see, Carl, you want to get us going on lava in the Grand Canyon, also the namesake of one of the biggest rapids down there?
Sure. It fits in with this idea that the Colorado Plateau region is tectonically active. It's a restless part of the world. There's earthquakes, there's volcanism, there's uplift, as I mentioned earlier, and these things all interact to create the landscape. And maybe if you show that slide that has the basalts down at the river, you don't see them in the Eastern Grand Canyon, but the Western Grand Canyon had lava flows that poured over the edge of the Grand Canyon, came down and dammed the river. About 17 times is our latest estimate of the number of lava dams where the lava poured into the river, blocked the river, stopped it for a while, short while, and then the river asserted water strong, water cuts through everything. And so the dams.
Carl, which slide did you want?
As a picture of the river and a basalt. What number is it, Laurie? I don't know. Oh, you know what? It's up there. Maybe number 9, somewhere around number 9. And so these dams are they're telling us something. They're telling us that you can't dam the Colorado River for long periods of time. We have 2 man-made dams, biggest reservoirs in our country, Lake. Okay, now let's see. Go up or back till you see a picture of the river with a basalt. And so the volcanism is spectacular. The lava dams. No, okay. Let's see. Number 4. Oh no. Do you see it, Laurie? Oh, but there it is. Number
14.
14. Yeah. Okay. 13. So this lava poured over the sides. You can see how high the sides are up there. It came down into the river, turned and went downstream, and it flowed downstream up to 50 or 60 or 70 miles downstream. And when it did that, it plugged the Colorado River, and it took the river, we estimate decades to maybe 100 years to break through the dam and reassert itself. And you can see on this one, the basalt overlies gravels. And so right where that date is 312 plus minus 11, we dated that basalt. It's 300,000 years old, very young basalt by a geology standpoint. And it flowed in on top of gravels. And now those same gravels, of course, are at the bottom of the river. And we can estimate how much the river has carved since 312,000 years ago. And it's carving, you can see, at about 90 meters per million years on average. That's about the thickness of a piece of paper every year on average. So the basalts tell us about an active landscape. They tell us about dams, which the fate of our man-made dams is undoubtedly the same as the fate of these lava dams. That is, they're not going to last more than 100 years. And they provide a tool for us to estimate the rate at which the Colorado River is carving through the Grand Canyon. So the volcanism is a spectacular chapter that is present in Western Grand Canyon. Lots to tell us.
Great. So we have a number of questions. This is a technique question, and it is the technique people are eager to know about is apatite. So apatite fission track analysis. And my challenge to you is to, in a very brief amount of time, tell us what it is and answer this question about how it's used and how accurate it is. And I realize that's a pretty tall order to do briefly and in simple terms. So want to take a stab?
Yeah. I if you could pull up the 1 hour slideshow I have on the side, we could go through it. But no, the concepts aren't hard. The technology is really hard, and the uncertainty is still rather great for these thermochronology methods, and there's several of them. But the concept is that rocks, as you go deeper in the earth, the rocks are hotter. And as a rock is brought to the surface by erosion, it gets cooler and cooler and cooler. So you have a bunch of different minerals, and they're called thermochronometers. And you ask these minerals, when did you cool through? In the case of apatite, it's a range of temperatures, but apatite records or remembers when it cooled between about 100 degrees and 50 degrees Celsius. So still not at the surface, but it's remembering part of its path towards the surface. Apatite fission track is another thermochronometer. It remembers more like 110 to 60. Apatite helium, same range to a little lower temperature. And now a new method that's quite controversial is zircon helium. That is the helium composition in zircon crystals. There's all other thermochronometers, but the concept is simple, and that is minerals have different closure temperatures, which means they remember different parts of that erosional history as rocks came to the surface. So the exciting thing is for thermochronology and for those of us who use it is you look up in the air, you're standing on the rim at the south rim of Grand Canyon, you look up in the air and you say, okay, this rock that I stood on got to the surface through a cooling process. And if I can get its cooling history, I can envision landscapes that once existed up in the air above me. And it's super powerful. There's a lot of complexities. There's still a lot of argument about the techniques and how they interrelate and the precision and whatnot. But the thermochronology breakthroughs of imagining past landscapes that have been eroded is a spectacular new part of our science.
Well, I think you did it. You made me want to learn more and not less with that explanation. So I appreciate that. That was great. We have a question about drought and water supply and springs. So Charlie Donaldson wants to know, has the current drought affected the springs at Moanave, am I pronouncing that correctly, and other reservation locations? Crystal, do you want to take that one first?
Sure. Yeah, throughout this region, springs have definitely been impacted by drought, as well as alluvial well systems. Groundwater sources have been impacted in this region. Unfortunately, we've experienced the severity of the drought by being able to notice other things, maybe not just the water availability within natural holding ponds or man-made reservoirs, but also by being able to notice the landscape changes. So changes in vegetation not being there, but then also dune migration has been pretty prevalent, and being able to see, these windstorms that we've not experienced in the past, more severe across this region, and being able to see, changes in migration are also impacts of drought in this region. The Navajo Nation Department of Fish and Wildlife has evaluated these efforts by looking at mule deer population changes, but then also looking at, the wildfire occurrences in this region. What's also evident about drought is bark beetle infestation, and being able to see trees in this region die off as well. And so, not just looking at the liquid phase of water aspect, but really looking at other areas that drought has impacted has really been challenging in this region, and being able to try to think about ways to be able to mitigate against drought is something that has been occurring as well.
It's fascinating just to hear about all the different ways you can ask those questions and look for signs of trouble. Lori, was there something you wanted to add about that?
Crystal, you really brought that forward, and showing the connectedness and the far-reaching effects of drought on every aspect of life in the Southwest. So yes, this kind of long view and the recognition of the change that's arriving to this region is going to be very important for planning moving into the future. And it's wonderful, and I'm hopeful that the Indigenous voice continues to be part of that conversation as it is right now.
I wanted to move on to a question about fossils. Valerie Thurman wants to know, what fossils have been found in the canyon and what age are they? Again, we could take another hour to talk about this, but I'm
happy to take a little stab at that. And it might be handy to, if we went to one of those slides, Emily, from Lippin Point, that gives us kind of a good long view of the history that's recorded in Grand Canyon. Probably one of the more famous fossils in Grand Canyon are the trilobites of Cambrian age. And Eddie McKee, I've found just some incredibly gorgeous specimens of the trilobite family, which sits, this one's okay, it's annotated, gives you a few kind of labels on there. So I'm talking about the Keats sandstone just above that red line indicating an unconformity of missing time. And it was the Cambrian seas, early Paleozoic, the great, the time just after the sort of the explosion of life that heralded the beginning of the Cambrian, which is the beginning of the Phanerozoic, the time of visible life. So we can think of those macrofossils moving up through the different layers, and there's crinoids and all sorts of things in these upper stratigraphic layers. But remember, the Kaibab is also in the Paleozoic, the ancient life. I saw a few questions about people asking about dinosaurs. Why aren't there any dinosaur fossils? Well, the Kaibab is too old, and the rocks that were on top of that, if you think of Carl's thermal chronology, once the rocks of the Grand Staircase were on top of this Kaibab, and those have stripped and retreated to the north, into Utah. And to find those dinosaur-bearing rocks, we need to go into those younger layers. Probably they did once reside here, but they were stripped back long, long ago, way before humans were in the Grand Canyon area. Now, if we think about microbiology and the microbes, and there's a few questions in there about microbial life, if we get down beneath the Great Unconformity and we look into the tilted supergroup strata, we find down at the very oldest sedimentary layer on top of the basement, that's called the Bass Formation. It's the oldest formation in the Grand Canyon supergroup, in the Unkar group, which is the lower half of that gigantic 4+ kilometer stack of sedimentary rocks. We find evidence of stromatolites. So we do have records of very early life before visible life on our planet. And then as we move up through the supergroup, we have an incredible record. Mostly it's a record that requires, at a minimum, a hand lens or even more techniques to discern the shapes and to identify the different species. In fact, the first heterotrophs were identified in the Chuar group of Grand Canyon. So it's a place that's famous for paleontology in different parts of the time period.
Lori, remind us what a heterotroph is.
Oh, a heterotroph is like us. It's something that eats a lot of different types of things, as opposed to an autotroph, which is at the very base of the food chain, that is directly building itself from things like the CO2 in the atmosphere.
Got it. Thank you. Carl, it looks like your video is working again. We were concerned for a second. You're all good. All right. Let's see. We have another couple of minutes for questions. Marjorie Burns.
Carl, would you mention, this ties into the trilobites. My mom used to say, well, how can you keep working on the geology of Grand Canyon? Don't we know everything already about it? And Carl, why don't you mention something that's pretty awesome, which is shifting the age of a famous unit like the Tapeats by, a couple of tens of millions of years, which ain't easy to do in today's geologic framework.
This is a good picture to look at that, and we look at the Tapeats, the Bright Angel, and the Muab. That's called the Tonto group, and as Lori says, it's during this singular time in Earth history where animal life developed the kind of diversity that we have today, and the reasons for the diversification of life, the explosion of different species, and the diverse DNA is still being argued, but the timing of when it happened is a key aspect of that. And we've gone in with a team of people with new techniques to date these fossil biozones. And the trilobites, which you can they look like a little like horseshoe crabs, and sometimes we call them the cockroaches of the sea just because they were bugs, But they came and they went. A new species would radiate and go extinct and then be replaced by another one. And this evolution of species, now we're getting very precise ages on, and everything's happening faster and younger than people had thought. So as Lori says, to go into a series of layers that have been studied for 100 and some years and be able to redefine the rates of deposition, the rates of biological evolution with new numbers, new numeric ages, is really an exciting part. And Grand Canyon, because of this spectacular exposure, not only in this particular view vertically, but as you go from east to west 270 miles and see changes along the shorelines, it's gonna, these discoveries we make at Grand Canyon can sort of resonate globally in terms of changing our ideas about the geologic timescale and biological evolution.
Okay, I'm gonna close out that video or the slide. So many great questions here. Sunil Srivastava wanted to know what kinds of microbes are in the Grand Canyon. Are there any unique species? And I would like to know if Tolio is a myth. When I was working down there, I got that thing that eats the flesh between your toes. And
it's not a myth.
Is it unique to the Grand Canyon, and are there any other notable microbes that we should be aware of?
Lori, that's for you. You've got to be the microbe lady.
Well, as far as the things that are carried by people, another example would be norovirus, which has been kind of highlighted in the news recently. Those are things that are carried by the humans that are in the canyon. So I would think more about some of the endemic microbes. When we think about our advances in microbiology and even in the use of DNA, that has its foundings in studies that were done in Yellowstone National Park, trying to understand what was growing in these really, really hot springs. So that was kind of our beginning of an understanding and of ability to do what's called PCR, which is polymerase chain reaction, taking advantage of what thermophiles do to cycle in a laboratory, to artificially do a thermal cycle, which they learned, the biologists learned that from what the microbes did. So talk about traditional microbial knowledge, Crystal. Even the microbes have methods that are useful to people. So what about in the Grand Canyon region? We have, if you look at the Colorado River itself, that's a very cosmopolitan environment. The river, is flowing hundreds of miles and it's connecting these reservoirs. So that's a very, like going to a lake, you find a huge host of types of microbes. But the springs that are just these little, in a way, they're islands of an aquatic environment in a sere desert. That is sort of a recipe for endemism. That is unique organisms that persist for thousands and thousands of years, reproducing in this environment, which is sustainable because of its groundwater feed. And that are some of the unique microbes that we find. There was a picture of Pumpkin Spring. So the rafters here, the river rafters, will be familiar with Pumpkin Spring, which looks literally like a pumpkin, has a very interesting brew of microbes. So just like the black smokers in the middle of the ocean have advanced our knowledge of extremophiles, things that help astrobiologists understand what kind of life might we expect under very, very different circumstances, places like the Grand Canyon host some of those same types of extremophiles.
Great, thanks so much. Okay, we're gonna wrap up. We're gonna ask one more question, and the question is really sort of a forward-looking, what can people do to protect the groundwater of the Grand Canyon, to support the communities in the Grand Canyon? What can people who care about the Grand Canyon do to show their love? Let's see. Crystal, would you like to begin?
I think it's important for people who love the Grand Canyon, be able to have that interaction with the Grand Canyon, is to be able to be conscious about the Grand Canyon. And so thinking about, not only our recreational aspect of the Grand Canyon, but really having an understanding that there's a bunch of life that relies upon the region of the Grand Canyon, and to think about it holistically, that the Grand Canyon is not just a place for humans, but also a place for plants and animals and birds and microbes, as we've heard today, and even like other insects that may be within the water, or even, depending on water, that are unique to spring areas. And some of the life that relies upon the springs can be very unique in this region. And sometimes, for some of the areas that are adjacent to the Grand Canyon, plants that you can be able to find only in those areas that might be near springs. And so it's important to think about preservation as a whole, being able to be familiar with what the issues may be. And we've heard about a threat of uranium mining in that area, but then also, just the drought impacts, and thinking about being aware of the current situation with the drought and how that may impact the operation of the system. And so not just thinking about the two main reservoirs that are there now, Lake Powell and Lake Mead, but really familiarizing yourself with how things are managed in the upper and the lower Colorado River system, because even though it's just the boundary of the Grand Canyon National Park, it's really a part of a larger system. And being able to be familiar with these issues in the Southwest, we can be able to be better to make knowledgeable decisions based on the information that we gain by being able to be researchers in these different opinions, and being able to have an understanding about, different perspectives and how the overall system may be impacted in different ways.
Well, thank you. Thank you so much for providing some of that knowledge and context and sort of enriching our understanding of this area today, Crystal. Lori, would you like to go next, or Carl, sort of let the two of you decide?
I'll just be very brief and emphasize what Crystal was mentioning. And so whether you're there as a researcher, as a recreational, whether you're hiking, whether you're rafting, whether you're taking a helicopter or visiting Grand Canyon West, is that we need to think about respect. And it's not just the ecological respect that you dwelled on, I think, Crystal, but also the respect for the traditions and cultures of the indigenous people themselves. I think early in the U.S. history, there was this thought of damming the Grand Canyon, and that was saved. And in part, it was a very evocative analogy that was used to say that damming this up and covering this landscape would be akin to filling up the Sistine Chapel with water so that you could be closer to the painting of the ceiling. And so that idea of something that was so sacrilegious to the readers of the New York Times or whatever was used then. But I think we need to think of these places like the Confluence, like the Sipapu, and other locations in the Colorado Plateau and the Western U.S. and all over the world, which are the equivalent of the Sistine Chapel to the cultures that were here in these places since time immemorial. So respect, that's, goes a long way.
Carl, do you have anything to add about sort of what people can do to protect this place?
I love the word stewardship. How are we stewards of our time and our places where we live? And I think Grand Canyon is a focus for so many things that involve stewardship. And I want to mention a couple concepts. Science education is so important right now, and the National Park Service has a role to play in terms of informal science education, and for people to come there and get a teachable moment in terms of the importance of science. And then the idea that the stewardship doesn't have boundaries, and here are all these associated tribes around that are also, their whole history is involves stewardship. So that concept that the Grand Canyon can be a focus point for dialogues amongst different people, all interested, sometimes in different ways, but interested in the idea of stewardship. And so I think Grand Canyon, the other parks too, other places, but it's incredibly important to bring different people together under this concept of stewardship.
Well, I, for one, have found this dialogue to be really interesting and fun, and it makes me want to know so much more. So thank you so much, Crystal and Carl and Lori, for joining. Thank you to everybody who submitted such wonderful questions. We're about out of time, but I just wanted to thank everybody who joined today for supporting Knowable Magazine and attending these events. And to encourage you to continue to support us by donating at knowablemagazine.org/donate. I would like to thank the Gordon and Betty Moore Foundation for their support of Knowable Magazine. And then just, guys, it's been so nice. Thank you. I'm really glad we got to spend this time together. This conversation will be posted on the Knowable website. It's going to be free to view and share. Please view it and share it. And then we're going to be posting the additional resources. Some of them have been mentioned in our conversation on the site so that you can go and dig in deep, get even deeper into this grand subject. And please do that. Also, keep up with us by signing up for our newsletter and following us on social and all of the things we've mentioned earlier. So we will see you again at our next event in September. And thank you again so much for joining us. And I'm sorry that it's over, but it was really wonderful while it lasted.
Hi, Crystal. It was nice to see you.
Yeah.